In this lesson, we're going to talk about graphing inequalities. By the end, you should be able to discuss the relationship between the inequality and the boundary line and graph inequalities on a coordinate plane. How many times have you been to the store and thought, I have this much money and I want to buy this amount of things, but I'm not sure how many of those items I can buy? Well, you're in luck. An inequality can help you solve all types of problems like this. If you had $10 and you wanted to buy some candy and gum, and candy cost $1 and gum cost 76 cents, how much can you buy? Remember that you don't have to spend all the money, and maybe you just want to buy gum, or maybe you just want to buy candy bars. Well, if you're buying gum, you could spend up to $10 on gum. If you're buying candy, you could spend up to $10 on candy. So you're not limited to specific amounts, but you have a range, a boundary, a plane of things where of options that you could have. To represent this situation, we would represent it using inequalities. The difference between an equation and an inequality is that when we graph an equation, our solutions are limited to the points that are on our line. So our solutions are limited to everything that's on the line. So when y equals 2x plus 3, our only solutions can be points that lie along that line. There are specific points. And we talked about earlier with equations and inequalities that equations have one solution, inequalities have many. It's the same principle here. Inequalities have solutions that can lie on the line, but they can also be below the line, or they can be above the line. There are many more solutions that we could have for an inequality. There are all of the points that could lie above or below the line as well. And it may or may not include the points on the line depending on the type of inequality that we're looking at, if it's greater than versus greater than or equal to. These half planes and boundary lines. Your line divides the coordinate grid into two planes. And each of those planes, or each of those regions, is called a half plane. And they don't necessarily look half, because remember that when we're looking at a graph, we're only seeing a snapshot of it. That graph does continue beyond the picture that we see. So it is half, but we might not be looking at both halves at the same time. The inequality is what's going to define the boundary. So your inequality is going to graph that line, and it's going to determine the boundary. And then the boundary line is determined by the inequality symbol. So if we have greater than or less than, then it would be dashed because we don't want to include the points on the line. So in order to say, hey, we don't want to include the points on the line, we represent it with a dashed line. And if it's greater than or equal to, less than or equal to, it's a solid line because we're saying, hey, we want to include the points on the line, so we're going to make it solid. When we're graphing an inequality, our steps to graphing an inequality are to graph the inequality. You can use a table. You can use the intercepts if it's in standard form. You can use slope-intercept form. So you can use the three ways that we graph any linear equation to also graph the linear inequality. The biggest thing here is that you want to determine whether the boundary line should be dashed or solid. So by looking at that inequality symbol, greater than, less than, or greater than or equal to, less than or equal to. And then you want to plug in a test point, such as 0, 0. And you're plugging in the test point to figure out where you should shade. If the test point is a solution, which means that when you plug it into the inequality, it makes the inequality statement true, then you want to shade in the region where the test point is located. If it is not a part of the solution, then you want to shade on the other side. You want to shade in the region that does not include the test point. So here we have the following inequality. We have 2x plus 3y is greater than or equal to 6. This is in standard form. So recall that we can graph standard form by using the intercepts. So to find the x-intercept, that's where we make y 0. So it's 2x plus 3, 2x which was formerly 3y. We plugged in a 0, so that's gone. 2x is greater than or equal to 6, so x is greater than or equal to 3. We also have 2x plus 3y equals 6. We can find the y-intercept, so we can make the x 0. So this would give us 3y is greater than or equal to 6, or y is greater than or equal to 2. So we have an x-intercept of 3, 0, and a y-intercept of 0, 2. And then we want to graph this. So making my graph, I know that my x-intercept is at 3, and then my y-intercept is at 2. And we're going to graph our line. Now we want to determine, is it dashed or solid? So we look at our inequality symbol that's set greater than or equal to, so this tells us that we have a solid line. And then I need to figure out, do I shade above or below? So we're using our test point, that 0, 0. We're going to plug in 0, 0 into our equation. So 2 times 0 plus 3 times 0 is greater than or equal to 6. This whole side becomes 0, is greater than or equal to 6. We know that 0 is not greater than or equal to 6. So this is not a solution, so 0 is not a solution. So this tells me that I want to shade on the side that does not include that point of 0, 0. So we shade on the other side. Had it been true, had it met the qualifications for that, then we would include, and then we would have shaded on that side. So here we have a graph or an equation that's in slope-intercept form. So if we wanted to graph this one, what we would do is you could make a table. So we could take our table -2, -1, 0, 1, and 2. These 5 points are easy points that we usually like to use because they give us a good description of the graph on both sides of the origin. So if I plugged in -2, this would be -2 times, or 2 times -2. Minus 1. We don't necessarily want to include the inequality sign when we're making the table of values. So we'll kind of ignore the inequality sign for right now, and then we'll go back and refer to it a little bit later. But 2 times -2, that's -4. Minus 1 is -5. We've got -1, so 2 times -1 minus 1, that's -2. 2 times -2, which is -2, minus 1 is -3. If I plug in 0, that'd be -1. And then we have 1. And then we've got 3. So if we notice, our graph is increasing, our slope is increasing by 2, and we should see that change in our table. So if we're graphing these points, again, we've got a point at -2, -5. So again, my graph might not look perfect, but we just want to get a good, or a decent picture of what our graph should look like. So 0, -1. We've got a point at 1, 1. We've got a point at 2, 3. And so as I'm graphing, I want to keep that in mind. Okay, here's my points. Now before I draw my line, we want to look at our inequality symbols. So this is where our inequality symbols kind of come into play. We've got greater than here, so that's not equal to. So we have a dashed line here to say, hey, we don't want to include the points on this line. And then we're going to look at where to shade. So remember that we want to look at a test point, such as 0, 0. We want to plug in that point into our equation, or into our inequality. So we have 0 is greater than 2 times 0 minus 1. We're using that test point. The x was 0, the y was 0. Easy point for us to use. So when we plug that in, we get 0 is greater than -1, and 0 is greater than -1. So this tells me, hey, we're going to shade everything that includes everything that's above or greater than our line here. Now, a quick little hint or tip here is that anytime it's written in slope-intercept form like it is here, the inequality sign will also tell you which side to shade in. We don't want to get used to this though, because if it's written in other formats, then it's not particularly helpful for us there. If we graph the inequality using slope-intercept form, we first have to get it into slope-intercept form. So we're going to change everything around. Now, I could distribute, but I'm not going to do that because that's going to cause me to do a little bit more work in the longhand. So remember, we're moving everything away from y. We take care of the things outside of the parentheses first, such as this multiplication of 3. So divide both sides by 3. What I'm going to be left with is no longer do I need the parentheses. We're going to have x plus 2y is greater than -9. I can subtract x on both sides now. So again, we're moving things away from the y. So 2y is greater than -x minus 9, and then divide by 2. And get y is greater than -1/2 x, x over 2, minus 9 over 2. So if we graph this, we're starting a graph at probably 4.4, 4.5, or 4.5. Start our graph at 4.5. So at -4.5. So it'd be here. And then we're going up 1 and over 2, up 1, over 2, up 1, over 2, or down 1 and back 2. Nope, I lied, because our slope is negative. So from 4.5, we're going down 1 and right 2, or up 1 and back 2. Because again, we should have a negative slope. We're using a dashed line here. And because this is in slope-intercept form, the fact that it says, hey, we're looking at everything greater, and I want everything that's above. Again, if we use that test point of 0, 0, because 0, 0 is in the shaded region, it should be true. So if 0 is greater than 1/2 times 0, that 1/2 part would go away, and that would leave us with -4.5, and 0 is greater than -4.5. So we've verified that we've shaded in the correct region. For looking at real-world problems, again, we want to make a table of possible solutions, including the intercepts. So delivery truck is transporting televisions and microwave appliances. The weight limit is 4,000 pounds. The televisions weigh 77, and the microwaves weigh 55. So if you're writing the inequality, this would be 77x plus 55y is less than or equal to 4,000 pounds. And so again, you would use your intercepts here to find the value. So you would make x0 to find the y-intercept. You would make y0 to find the x-intercept. And in that process, oops, undo that. In that process, and then in that process, you would be able to answer questions. So it says, will the truck be able to deliver 35 televisions and 25 microwaves at once? You can put in 25 for the televisions, so 25 here. You could put in 35 here and see if that value is less than or equal to 4,000. And in this case, it would not be. Same thing for this last one. Again, you're writing the situation, and then you are solving to figure out how many would be here. I'm not going to go through this one, but just know that it's similar to that last question. To determine the area, to determine which area to shade from an inequality, that is what I would like for you to consider before watching the next video. As usual, please subscribe to the channel so you get updates as new videos are released.